Hello everybody, welcome to our presentation about from idea to product. So my name is Sandro Strebl, I'm the CTO and one of the co-founders of Bring Shopping List. Maybe you have already heard of our app, I hope so. So Bring is a mobile startup from Zurich, and our vision is to build and market the most intelligent and social grocery shopping list app, and help millions of users around the world to save time and money. Already today, more than 500,000 users plan and execute their grocery shopping with Bring on a regular basis. And with Bring, we want to provide a space to which everyone from the household is connected. And we support our users in planning, coordinating, and doing their grocery shopping. Unplanned grocery shopping can be frustrating. You end up with too much milk in the fridge, but no eggs for the weekend brunch. An extra tour or an extra trip to the supermarket costs time, money, and is just a pain. But what if an app could remind you at the right time about items you ran out of? What if we could predict your next needed items? Wouldn't that be cool? So, as you see, we have this magic keyword, intelligent, in our vision. And our planned intelligent features, which are based on big data and machine learning, will give our users indications on what they still have at home, what they better buy during the next days, and also informs them about their shopping history. As you can see, data analytics and machine learning are an important part of our vision. So when we started, our goal was actually clear, but we were not sure if we really can provide those kind of features based on our data. Do we have enough data? What about the quality? Or maybe do we already see some patterns in our data? And what we needed was a high-level understanding of the current situation and of our constraints. We had to sharpen our intelligence use cases and prioritize them. We always had a very good relationship with Zülke, and when we heard of their data science services, we decided to start a feasibility project together. And in Zülke we found a partner that perfectly supported our need for this specific case and at this stage.
Okay, hi everyone, I'm Gian Baschera. I'm a lead data scientist at Zülke. And Zülke is a service provider that supports customers in building data analytics solutions, such as Bring was planning to do. And we condensed all our experience and knowledge we have from past projects into a data analytics process that covers really the entire life cycle, from creating the initial idea, building the product, and operate and maintain the solution. The next couple of minutes I want to walk with you on a generic level through this process and explain you what the individual phases are for. And then after that we're going to have a look at how we actually conducted this project with Bring. So let's get started with the data analytics process. Maybe it's not so much of a surprise that what's going to pop up here, because many of you have seen the poster out there already. But generally, we start with vision and scope. Let's assume a customer that have heard of big data, data analytics, all these terms, maybe has heard of a couple of interesting use cases, but they ask themselves, what's in there for us? So how can we leverage our data to generate an additional value? And this is when we really start at a very early point, and we're not talking about data and data analytics solutions. We investigate the business value chain. So we really look at what the business currently is doing and where are the main pain points, where is potential for improvement, and where do they think that they can benefit. And this is where we generate rough ideas about what could we improve in the business. As soon as we have a lot of use cases, we start to assess them and rate them according to some metrics. For example, what is the business value, the actual value that we create? What's the maturity already on the solution side? So what will be the effort to build it? What are the risks involved, etc. So this allows us to prioritize the use cases and to, in the end, select the most promising one in the beginning. And then, before we actually start building and looking at data, we further refine such a use case. So here sometimes we even go as far as building a business case draft which describes the use case, describes exactly what's the business gain that we expect, that's a dollar sign, who are the users that are going to work with the solution, and also what's the actual product vision. In this case, a little lighthouse with a light bulb on top that is guiding the ships around. So what is the vision that we are actually trying to build with this data analytics solution? So at this point we made a lot of claims and assumptions saying that maybe we can predict something to a certain quality and so on and so forth, and we're going to use a certain amount of data, and there are a lot of risks at this point. And before we start, or before a company wants to invest a lot of money and say that we build a full application, they want to evaluate if this is possible or not. And this is what our evaluate and prototype phase is for. So here we want, as fast as possible, build a solid foundation for an informed decision on further pursuing this goal, this solution, this use case or not. So checking the feasibility, is it possible to do the predictions that we're planning to do? So what are we doing here? First, of course, we have to decide on a data analytics platform that strongly depends on the use case, the data we're looking at. But this is really just for the evaluation. So that can be in a small data stack. You can use just R, even if later on some other technology is needed. You have to acquire and access the data. There can be a very laborsome task in some companies to actually get access to the data that you need and collect it. Prepare the data, create a data understanding, what's in there. That's strongly linked with, you're working together with the business to understand what exactly is in the data, to decide, is this an outlier you want to remove, or is this the important information, which is kind of like an extreme cost that occurs from time to time. So there's a lot of data plumbing that has to be done at the beginning. Before we can go to the cool part where we can do the actual data analytics, building statistical models, evaluate them, visualize results, and inspect and discuss again with the business to get a better understanding of what we see in the data. So that's a very iterative process where you continuously try to improve your models and see what you can predict. So basically we're here now measuring the light bulb of the lighthouse. Is it really bright enough to guide the ships, or is it just a little LED shining to the top? So is it good enough, the data we have, to fulfill the business case? And that's one main outcome. So here we want to have the metrics so that we finally can calculate the business case. Do our assumption we made over here hold, and is it still worth to invest in that, or do we see there's not enough information in the data and it's not worth pursuing it? Another outcome we very often build is some sort of prototype. In the beginning I was always kind of like, that's the important part, just do the numbers, confusion matrix and some metrics. But often we have to show them how the solution will look like, such that end user can sit down and work with it, and that helps them to convince the people that should work with the solution that this is valuable, and we can check if this is really what they need, or sometimes that in this phase we realize that they have different expectation and they want something else. And an additional step is some sort of architectural concept. So maybe we've built something here with R or Python, and we have to figure out how we will bring this into their existing landscape, system landscape, and at least some architectural concept and project plan has to be delivered here, how they can further proceed. And at this point we should be able to make this go, no-go decision. So the business can say like, okay, now we've seen it's possible, yes, we want to pursue this, or no. We either have to pick a different use case, stop the entire initiative, or just change the use case a bit. If one wants to proceed, we start to scale up the solution. So that's the actual build and model phase, where we build the solid foundation, kind of like the lighthouse, that's a software around that where the intelligent application has to run, the intelligent model, and also fully build up this data pipeline. So operate everything, that there are no manual steps, you don't make all these simplifications and restrictions you might have done up here. Maybe you've just looked at one region, one product line to show what's possible, but here now you want to do it for full scale, for all your products and all regions. And then you build up these two models, and you build the model, you build the foundation, and finally you're ready to go, and you have a minimal viable product which you can release, where a user can actually start generate value from it. There might be, in operating extent, a first deployment support, such that you can help them get the application running, and also some rollout support. That's more in the business process level. So if you might give them an application that helps them to arrange their service, the service guys going to different places, you do the routing or something like this, you need also to inform the people how to use it and what they have to change in their processes. When things are up and running, there is again a cycle, so you continuously operate and maintain the software, and you also have to maintain and monitor the model, so that's on the maintenance side, and you also further enhance the software and enhance the models, so you need some sort of model change process such that you can continuously improve your solution. So up here we don't have the final product, but we have a minimal viable product which you continuously extend while running. So that's the entire process, starting from creating the idea what and why to build, to evaluate it as quickly as possible, and then build a first running version and maintain and operate it. So let's have a look how we did that now with Bring in the project. So in this vision and scope phase, as Sandro said, they already had an existing vision. So they wanted to become the smartest shopping app as a unique selling point, giving guidance to the user and increasing the usability such that people are going to use this shopping app and not any other of these myriads of shopping apps that are available. And they have a lot of users, active users, but they want to figure out what are potential ways how we can monetize the success. So these were kind of like the vision, the big goal, but then we made a step back and really started to investigate the shopping value chain. And we started from the very beginning, we did a jobs to be done analysis. We really looked at the entire chain from consumer good producers over to retailers, over to shopping activities such as figuring out recipes, assembling shopping lists, going shopping itself, cooking, eating. So we looked at the entire process and we tried to identify use cases where Bring can provide additional value based on their data they're having. So we identified use cases and we specified them further and prioritized them.
So as Gian Marco said, we gained some important inputs for our vision, and furthermore we identified and clarified two use cases. And the first one, intelligent shopping support. Here we see three more detailed use cases: reminders, predictions, and recommendations. Reminders and predictions, for example, could be based on the cycle time of a product. So we can remind you at the right time about needed products and can predict your next best item. And the third use case, recommendations. Here we can analyze millions of baskets and recommend magic products to your current basket. And the second high-level use case was consumer insights report. Here automated consumer insights reports could help us establish a new revenue stream. So for example, data telling at what point in time a customer is interested in a certain product could be very valuable for a retailer or a brand. Based on such data, they can approach their customers with their message even before a customer has decided what exactly he wants to buy. And another valuable output for me was that we identified our main data sources, which gave us input for our future data architecture landscape.
Okay, from now on, we're just going to look at the one use case, intelligent shopping support, but we pursued here in the project with both cases. So now we're looking at evaluating prototype. We try to figure out, is it possible to do these things based on the data? So in the beginning, we had to access the data. We Spring is storing all the user interactions, so whenever you put an item on the list, or you take it off, all these interactions are stored. And you provided every 2 months a dump of the entire database, such that the data is still available. And we collected this for approximately half a year, we loaded it in, and started to prepare data in R. So we used R for this project. And there was some data understanding preparation. It wasn't too complex because it was mainly this user interaction, but there were a couple of things which had to be cleaned. So for example, sometimes the interaction is stored, the icon is put on the list, and it's put on the list again before it was taken off, which was due to some synchronization. And there were a couple of things which you had to clean up, but it wasn't too big of a deal. And then we went into this modeling phase, and there are a couple of models and results I want to show you that we delivered. One is regarding the cyclicity and seasonality, where we looked at, on one hand, if an item is bought, when is it bought again, when is it bought again, is there a cyclicity? And the other thing is a seasonality of shopping behavior. And this is just one result where you can see some items they can buy, and up here you have the autumn, here is New Year's Eve, and Christmas a bit before, and over here it becomes spring. And we can see the red shows where they have put it on the list more frequent than at other times. So, for example, you can see fondue, that's very before Christmasing. Champagne goes up to New Year's Eve. Gift wrapping paper, it's really close to Christmas. On the other hand, client strawberries is much more in spring, and there's nothing in winter, asparagus as well. And we can also see that strawberries should be a bit later in time than asparagus. I hope that's correct. I don't even know it. But you could say, like, we know that. I mean, you can look these kind of things up and just put it in your software. But these things might change these seasonalities in different regions in the world. This seasonality also changes strongly if you have different items. So maybe you're having this app deployed in China and you don't even know what these items are, or you have no clue what seasonality is. You can do this on a regional level and just extract it from the data. So that's about seasonality. Another thing we were looking at is we analyzed the item relationship in the shopping basket. So Bring has the unique opportunity that they know when people are thinking about food and thinking about grocery shopping. If you're looking at Coop, Migros, they know when people go shopping, and they have a huge basket and they have stuff in there for breakfast, for lunch, maybe for a party and weekend. It's all in the same basket. But what we were looking at here is that we did not just took the entire shopping list when they go shopping, but we were looking at when they assemble the shopping list. And on the temporal coherence set, we say like, well, that's now in the last 5 minutes they assembled a list. We say like, that's a shopping list. And if they put additional items on the list the next day, we consider this as a different list. And then we were doing a data allocation, considering these items on the list just as a text, and try to extract topics. And these were just 4 topics out of kind of like 12 or 15 that we had that were automatically extracted. So you see here milk, cream, sugar, eggs, flour, butter, yeast. You probably know where this is going, somewhere there's baking. There's more the Asian cooking type of grocery list. Here's some meat sauce, mozzarella, ham, pizza dough, someone is baking a pizza. So this was all automatically extracted from the data. And you can do this for different regions. Going to Germany, you might, even already in Germany, in different countries, even much more, get completely different recipes they're going to assemble. And what we want to do here is now, if you add 1 or 2 items from a list, we can figure out what's the most likely thing you want to cook and start to provide you with some recommendation, what would be the next thing you want to put on. It's not that you're just going to put it on your list, but it increases the usability because you do not have to browse through the entire app looking for an item or typing it in. You can just put it as the next best item and you can assemble the list much quicker. Okay, so based on that we built a small prototype just with R Shiny, where they can, looking at historic data, saying like, let's take one user and what kind of items would be recommended and what did he take. They can also start playing around with this, say like, let's start to put some items on the list and let's see what it recommends to get a feeling for what these models would do. Maybe as a side note, also for the other showcase, the other use case, with intelligent reporting, we built a small prototypical report which they can then show potential customers and get feedback, so like, is that valuable information or not? So on that level, prototyping was done here.
So by the end of evaluate and prototype phase, it was the first time we experienced data analytics and saw concrete results based on our data. Meaning now all main data sources were actually accessed and we could operate on the real shopping events of our users. And this helped us to establish a common understanding of our use cases and how good or precise our use cases and predictions can be. And those first prototypes clearly showed the potential of our data, and we had the foundation to decide if we should proceed with the intelligence part in our vision. And of course, so we did. And what was also interesting while working together with Silke was that also new use cases evolved. So for example, one day our Silke data scientist came back with this seasonal heat map showing which products are when trending over the year. That was just amazing and a really great inspiration for new or for future use cases. And what I'm also happy to say is that the prototype infrastructure Silke built is so stable that we still use it today to generate ad hoc consumer insights report for our brand and retail customers.
You should have built a less stable prototype, right?
Yeah.
Okay, now the next phase, we've seen that we've built the foundation for a go, no-go decision, and I'm really happy to see that after that phase you decided to definitely continue with data analytics and even decided to put data analytics at the core of their strategy. So that's very good, and that also implies that if it's a core element in the strategy, it's probably a core competency, which also meant for Bring that they probably need to build up internal resources and not just fully rely on external resources, which is slightly bad for us, but still very nice to see that you continue with this.
Yes. So this is where we are today in the process, and we have a better understanding of our data landscape and which data sources and streams are the most important to us. And based on this knowledge, we have set up now data pipelines to process and archive relevant data for later use. At Bring, we have a big Amazon Web Services stack, so now our production server streams all shopping events. Streams all shopping events in real time to Amazon as free, and we use then decoupled data pipelines to load production data every night into our analytics environment. And this is our high-level approach to process data and create consumer insights report. But we have bigger plans. We want to build the mentioned intelligent shopping support. So as of today, we see the following three use cases, which I want to explain now a little bit more in more detail. The first one is predictions. So Bring can help you remember what you still have at home. Maybe often struggling with the same forgotten products. With Bring, you can create your own pantry view in the future and easily check the availability of a specific product. Also, Bring can give you insights on the product history. For example, have you ever been in the Migros asking yourself, do we have still detergent at home? In the future, Bring can support you with answering these kind of questions. And to go one step further, Bring might even remind you at the right time and the right moment about things you might need. And these products are triggered by the routines of our users and what they're most likely to buy. So for example, when commuting home from work, Bring can remind you, do you need red wine for the weekend? Or during a shopping trip, you might run out of toothpaste soon. Before you probably run out of toothpaste. And the last one is recommendations. So Bring recommends you matching products to your current shopping list. And users see the products that are the most relevant to the previously added ones, as Gianmarco explained. So for example, if you have added tomato, sauce and mozzarella, Bring can predict that you're going to make pizza and suggest ham and mushrooms. So these three use cases are on our roadmap now, and to build a fully working application and bring it to production, we need additional support in our engineering team. And that's why we are looking for machine learning engineers. So if you're a data scientist with some software engineering skills and would like to work in an awesome startup environment in the heart of Zurich, I'm happy to chat with you in the coffee break.
Alright, so let's recap. What happened on the data analytics process side? There's three main takeaways. So know what you want to build and why you want to build. Sometimes we end up here, kind of like we know what and we want to predict something, but make really clear why you're building it and what the business value is of it. Then as quickly as possible, evaluate the prototype, figure out the feasibility. So not building a huge application, huge stack, before you know that it's worth it. And then build a minimal viable product and continuously expand it while running.
Yes, and the biggest benefit for me or for Bring was, of course, that we confirmed the feasibility of our intelligent features. And personally, I don't have a data science background. I have a master in human-computer interaction design, but I now think more like a data scientist, and I am able to transform our current technology landscape into a more intelligent future.
Thank you.